Hello everyone, welcome to our webinar today. The subject of our webinar is how to use the solar panel supporting system generator feature in GRAITEC Advance Design. My name is Farshad Purshag. I am the Senior Solution Technical Manager at GRAITEC US and Canada. So let's go on with our slides and we are going to talk about some benefits of this generator. So this is a new feature in GRAITEC Advanced Design to help you to create the geometry of the supporting structures for solar panels. As you see, I have mentioned some of the benefits of this feature in Advanced Design. So first of all, it has versatile geometry modeling. You can create different kinds of geometry for those kind of structures. You can edit your geometry with specific tools that we have in this feature. Wide range of applications. Basically, we have so many structure types and geometry types that you can use in most of your projects to create the supporting systems. The interface is very efficient and intuitive, so you will see, and shortly I'm going to show you in Advanced Design how to work with the interface. Comprehensive output generation, so all of the results regarding the internal forces, deformations, stresses, even design results, you can get them from Advanced Design. And finally, you can customize and reuse the geometry of your supporting structures for solar panels that you have already created. So we have a system that you can save your templates and reuse them again in your other projects. So how to use this tool in Advanced Design? It's very simple. So as you see here in the list and in my screenshots, so in the Objects tab of Advanced Design, we have different generators. So here we have added solar structures or supporting system for solar structures. And when you click on that, you will see that a list will show up. So these are like different types of the structures that we have in this new tool. So single column, several columns, different kind of geometry. Then you just select the type of geometry that you desire. And after that, we will have the second window, as you see here, to basically put the parameters to create the supporting structure. So we start with the general dimensions, and we go more into detail to define the columns and purlins and sections, etc., to basically generate the structure. And this is totally the dialog box is interactive. And finally, after you're done with the definition of geometry, then you can click OK, and the structure will be generated in Advanced Design. Also, we have another option, which is save, that you can save this template and reuse it again in your other projects if you want to use the same geometry type. To further go in this presentation, I have actually prepared a conceptual design. So let's assume an example of a solar panel supporting system. So in this case, I'm going to be using and designing a structure which has like four types, 4x4 types of panels, and the dimensions will be, as you see here, these are in millimeters. So, and also if we want to see the panels, so as you see here, it's a 4x4, 4 columns and rows, as you see there. And then we are assuming the dimensions, as you see here, mentioned there. And also we assume 25 millimeters of a gap between each panel to add the clamps and joints and etc. So in total, these dimensions will be our width and length of the total planar area of our solar panel. So then here you see our purlins, which are going to be directly supporting our panels. And after that, you have the rafters, which are supporting the purlins and the panels using 2 columns and also a bracing system. So in total, you see the spans here, and we will assume that we also have some overhangs here on 2 sides. So yeah, as you see here, I have my purlins here, added some bracings in this conceptual design, the rafters, and also you see the columns here, and I also have a side view of the frame structure supporting the purlins, as you see here. So this is our conceptual design, and we will try to create this geometry in advanced design using the solar panel generator feature. So I will now switch to advanced design, and we can see this new tool in action. Okay, so I have opened Advanced Design. This is the new version, 2025 version. Just to give you an idea of Advanced Design, this is a full finite element frame analysis solution, which covers different country codes. For example, I can simply go to our configuration to select my code. So for this presentation, I'm going to use Canadian codes and standards, but just to let you know, we also have several country codes, and as well we have US codes. So if I click on US codes, you will see that we cover all of the AEC standards for either load combinations, climatic load generators, steel, timber, concrete design, as you see there. So, and also other country codes, as you see there. So I will just switch to Canada, and my language, I'm gonna select English, and we will click OK. So now we can create a new project in Advanced Design. I can click on New because we want to create our geometry. So this is gonna be the first page of Advanced Design. So as you see, you can import and some project names and properties here. In this case, I will just ignore this. We will close also the tips. And yeah, as you see here, Advanced Design is very simple to use. You know, in the right side, I have what we call our project browser. So all of the elements that you have in your structure, either geometry, loads, types of analysis, etc., will be listed here. Up here in top, we have all of our modeling tools, controlling the model, copy, move, etc. We have our objects, which today we're going to be using these solar panels. Different types of utilities that you can use to modify your model. So just to let you know, you can create any type of structure in Advanced Design. So, but in this presentation, we are focusing on the generator tool, solar panel generator tool that we have added to Advanced Design, which is actually here. So, and also on the right side, you will soon see that you can see all of the properties of elements or members that you will have in your model, basically. So let's click on solar panel generator. So as I mentioned earlier, here you can select the type of the supporting structure that you want to have, and in this case, I will select a two-column system, as you see here, and click OK. But again, as you see, we have different types of configurations that you can select. So let's go with two-column system and click OK. So here I have the option to basically input the parameters of my conceptual design that you saw in my PowerPoint. So let's input those values. So for the slope angle, as you see here, the slope of the supporting system or the top of the solar panel, I'm going to be assuming 25 degrees. And the width of the panel will be 4.56, as we decided before. For the start and end overhangs here, so P1 and P2, we will use 0.4 in both sides. We are not using top or bottom overhangs for this design. And also for column height, I'm going to use 1.86. And as you see, as I mentioned earlier, it's going to automatically adjust the parameters. So for the rafters, I'm going to use 2.5 meters. And just to let you know, in this scenario, I am using metric units, but you can also change the units in Advanced Design to imperial. So it's very simple. You just double click here, and then you can switch all of the units to imperial units. So again, after I'm putting this here, it's going to automatically calculate the other D1 and D2 spaces or the dimensions there. For the number of bays, as we decided, we will use 3, and the distance we will use 2.8. So that was like for the general configuration. And let's move on to the column configuration. Okay, for the columns, we are not going to do a horizontal offset, so it's going to be a vertical one, and we have bracing on the right side. So I will just put the check mark there, and we are assuming that it's a 45 degrees, so we are using to 1.4 meters for both horizontal and vertical spacing. So, and we are not going to add a second column or etc. Or modify the second column. So that's gonna be as you see here. And the other step is defining the properties for the purlins. And for the purlins, let's define them again. What I'm gonna do here, our number of purlins was 5. And as well, we are not going to use E1 and E2 in this case. And we, as you remember, we defined overhangs for the purlins, which was 0.4 meters for each side. So that's also defined. And finally, we are defining our cross sections. So for the cross sections, you have different options here. In Advanced Design, we have different types of sections. So for example, if I click here, you can define a customized section. And also we have cold form or light gauge sections that you can assign to your elements. After that, you can also assign compound sections that we have here. And finally, you can also assign sections from library. So in this case, since we decided to use Canadian code, we can simply go to our Canadian code sections. So here, and let's go to CIC. But by the way, again, we also have all of the AEC sections here. As you see that you can assign to your structure here. So I will just go to the CISC sections here, and let's assume that we will use CIC channel section. And again, for the purpose of this demonstration, for example, we can use C 100 by 11. Okay, I can click OK. And as you see, it's going to be assigned to our columns. So let's assume the same section for the other ones. So again, if I go there, it's already added to my section list here. So it's going to be very fast. So we assigned these channel sections for all of those geometry. For the material, same thing. I can go and select my material from here. Or you can also define a customized material. So again, we have full libraries here. I can click there. For example, for steel, I can switch to my code here, like CSA. And as you see, we have all of the material type or standards for Canadian code. So for example, if I want to use the 400 grade, I can just import it here, and it's going to be imported in my list here. As you see there. Okay, so I will click OK, and yeah, let's assume we are assigning 400 grade, and again I will select the same material for all of my sections from my list here. There you go. You can have the column extended below the soil level if you want. The generator has that capability. I'm not going to use it now for that, for this example. And as well, it's going to also automatically apply the supports, either fixed or pin support. So for example, let's say for this scenario, I will use fixed supports at the bottom. So let's click OK. And by the way, before clicking OK, I can save this template, so I can use it for my other projects. So let's try this. So I will click Save. You see, a new window will be opened, and I can actually save this template. So next time that you want to use this template for other geometry projects, you can just load this template, and you will be good to go. Okay. So let's name this like test 1 and click OK. So it's going to be saved and it's going to be displayed when you are starting your template. So let's click OK. There you go. The geometry is created. So let me just rotate our structure. For now, I will deactivate my grid plan. Okay. So as you see here, the full structure is generated automatically as we defined. Just to show you, we have the template. If I go back to that model again, when we are creating the model, you see test 1 is already added to my save template. So next time you can just directly access it from there. So now that we have generated the structure, just to let you know, this structure is also can be easily modified. For example, if I click here, I will see the properties, all properties of my section. So if you want to change something for because of steel design, end conditions, or etc., you can definitely do that. For example, let's try that out. Let's say I want to assign hinge conditions for the ends of bracings. Very simple. I can just select my braces. There you go, for braces. And in the properties of those bracings, I can go to my end conditions, which is going to be here. And I can actually release them for both like rotation in both RY and RZ in both ends. Okay. So now my bracings will be basically having hinged conditions in both ends. Or any other type of configuration, you can just assign them if you want. For example, if you want to define some extra braces in this direction, that is also possible. I can go and use the Advanced Designs member addition tool here. So linear element, I can add it there. I can define my sections. Let's use the same sections that we are using for the others. So the material was 400. And my section, I'm going to use the same section here that we used for that. So it was C100 by 11. Okay. So we select them and very simply, I can add my braces here. Okay. This here, there you go. And I can simply snap on that position. Okay. Same thing for the other side of this X bracing. I can just click that and just zoom in, and Advanced Design will automatically snap on the point that we want. Just zoom in, and there you go. So we can have a similar bracing for the other short columns. Same here, just click. And again, the nice thing using Advanced Design is it's going to snap automatically at the points. There you go. So we can see the full view here. Okay, so let's say we have the geometry here. By the way, our also load area to distribute the loads in between the purlins has already been created. And as you see here, by default, it's going to be a two-way load area, which is going to distribute the forces in two directions. In this case, I want my forces to be distributed in one direction, so directly going to purlins. So for defining that, you can just select the load area, and in its properties, I can go and change my span direction. So now all of the forces and loads will be distributed on these purlins, as you see there. We can also add some loading on this structure. So either wind loads or, I mean, snow loads or any kind of dead loads. We can actually add the dead load of our panels here. So the self-weight of these rafters and all of the elements that I have here is going to be automatically applied to the model. But I can add another, let's say, dead load here. So you can just create a new load case family. Let's call it a dead load. and it's going to be called 1D. And you can just right-click on your load area, and you can use the load and selection. So it's going to be a planner, and let's assume vertical direction FC, and let's assume minus, for example, 10 kilonewton of force per square meters. For example, that's just an example, and we click OK. So as you see here, we have the dead load also added to the panel. Then the next step is going to be creating the load combinations based on Canadian codes. So we have automatic load combination generators in Advanced Design. I will just use a simplified combo, click generate, and automatically I'm going to generate some load combinations with some load factors. And again, here you have the option to create your own load combinations. So manually actually, and apply any kind of factor that you want. So I'm going to click OK. And now we are ready to perform analysis on this structure and also steel design. So let's perform the analysis. You can just go simply analysis, and directly I will go to do a steel calculation and click OK. So analysis started. As you see, it's going to be automatically mesh the structure. Here at the bottom, I have some warnings, which in this case, I'm just going to ignore them. But again, that's a warning that is asking me to check the lateral support and buckling lengths of my elements. So to see the results, I can click here. And as you see, this is going to be the form shape of the structure. Then I can also check my forces from here. Very simple. Let's say axial forces for each column. If you want to check the moments in any direction, like I can have this MX and MY, it's going to be the strong axis. And also you can check the other type of forces if you want. For example, we also have the shear forces in the structure. In terms of the reactions, also we can just simply go there, and the reactions, let's say you can go all forces, and you can see the reactions that you have here, either vectors or values for each basically support reaction. So these are like very simple finite element results. And now because we have performed steel design, we also have the steel design results here for my structure. To access them, I can simply go there. You can access them one by one. I mean, lateral torsional or buckling or just deflection criteria. In this case, for example, I can go with strengths. And let's go with the max. We can again check them one by one, but we can go max. And as you see here, that is going to be the design checks that we have here. We can activate also the values and make them a bit bigger. There you go. We can also modify the text scale. Yep. So as you see here, it can show us the maximum and minimum design load ratio for our sections, and clearly we can see that we have some problems in those areas that you can check them even more in details. Okay. So if you want to change the forces, you can simply go back, and again, it's very simple in Advanced Design. I can just click there. Let's say if our solar panels they are lighter, for example, I can use like -2. And we can also do an auto scale. There you go. And now we can run the analysis again. Okay. So now if we check our steel design, you will see that the design load ratios are dropped, as you see here, maximum and minimums. Okay, so if you want to go more into detail, for example, if you want to see the steel design checks for any member here, let's say this column, you can just select it here and we can access the shape sheet here. And this is going to be the properties of that section, some deflection checks if you have defined the parameters before. And finally here you can see the code checks of based on Canadian code or US codes if you have selected those. So it's gonna do all of the checks one by one as you see here, and finally it's gonna do the combined formula or interaction formula to get the final design load ratio. And you can also have some detailed reports. If I can go there, you can get some very detailed reports with numbers and etc. On that, there are actually like different types of report format. You can go there, for example, I just used an RTF, but for example, you can also have a PDF. Click there and you can generate also a PDF report as you see there. Okay, great. So yeah, that was like an overview of how you can basically analyze and design these types of structures very fast in advanced design. So let's go back to our slides. Thank you for attending this webinar. As you see here, if you want to try advanced design, you can always send emails to support.us@greatec.com or support.canada@greatec.com. And now it is time that we can have some questions, and I'm going to be answering them. So please use the chat tool for asking your questions. Thank you very much for your time.